Okay, for this video, we're going to analyze and sketch rational functions. So we're going to talk about domain, points of discontinuity, x-intercepts, y-intercepts, and asymptotes. I'm going to do 3 examples, and these examples are not basic. So what I mean by that is our denominator is some kind of polynomial, binomial concoction, which is not just going to be an integer that we can very quickly sketch. So it changes a couple things. First, our denominator, which is always the first thing you should go to, pretty much says our denominator for any rational function cannot be 0. That's where our discontinuity comes. So in this case, if we look at our denominator, x minus 4 times x plus 1, there are 2 numbers that make this discontinuous. X cannot equal positive 4, and x cannot equal negative 1. Positive 4 would make this discontinuous, negative 1 would make that one discontinuous. So we got 2 parts. These 2 parts are actually, the way you graph them is going to be different. So there's 2 types of discontinuity. There's a hole, which is what we call a removable discontinuity, and a vertical asymptote, which I did in a previous video, which is something that cannot be removed. So if we look at this function, y equals, the numerator is x plus 7 times x minus 4. Our denominator is x minus 4 times x plus 1. Hopefully you can see right away this fraction, this rational expression, has common factors. So x minus 4 gets removed. We can simplify it. Because of that, we have a hole in our graph. And our hole is going to be when x is equal to 4. X cannot be 4, but we can actually remove that. So that's where we have this thing called a hole. Once we take that out, we're left with a simplified version, x plus 7 divided by x plus 1. And here's where we see there's still a denominator. This denominator cannot be removed. So because this is non-removable, that's where we have our vertical asymptote. So our vertical asymptote is when x is equal to negative 1. So both of those values, the positive 4 and the negative 1, we cannot use in our graph. But they're going to look very different when we do these. So to find your x and y intercept, the last 2 parts of this, we just plug in values. So now that we have a simplified version, y is equal to x plus 7 divided by x plus 1, we can use this equation to find our x and y intercept. So for the y-intercept, when you plug in 0 for x, you would get 7 over 1. So our y-intercept is going to be 7. For our x-intercept, when you plug 0 in for y, what you actually get is 0 is equal to this fraction. When we cross multiply, the 0 times this denominator is going to go away. So 0 is actually just equal to x plus 7, and we could solve that. So our x-intercept is going to be when x is negative 7. So again, we're doing 3 examples, so this is just the first one. So this is going to help us figure out how to graph all this. So we have a hole, vertical asymptote, an x-intercept, and a y-intercept. So here we go. Our vertical asymptote is when x is negative 1. So we are not going to be able to touch that vertical line. We have a hole when x is 4. So the thing is, 4 is going to have a y value. And we're going to need to figure that out to graph it. So our simplified version of this equation, x plus 7 over x plus 1, if you plug 4 into that, you would get 11/5. So our hole is literally going to be a point at 4, and then 11/5, which is 2.2, somewhere over here. Instead of having a closed circle, we're going to have an open circle. So we have our vertical asymptote, we have our hole, our x-intercept is at -7, 0, and our y-intercept is at 0, 7. So 1, 2, 3, 4, 5, 6, 7. There's our y-intercept. Our x-intercept, 1, 2, 3, 4, 5, 6, 7. All right, so we have our points. Point, hole, vertical asymptote. So your horizontal asymptote, I'll just do very quickly. It's dividing your leading terms. So because your numerator has x times x, it's going to be x squared. Your denominator is x times x, which is x squared. When you divide those, you get 1. So our horizontal asymptote is going to be y equals 1. This is the very quick and easy horizontal asymptote tutorial. So now you could see your 4 sections. And we know this is a rational function. So we know it's not going to touch the asymptotes. And we just have to graph it. So it's going to have the same shape. It's going to come down. It's going to go through that hole, but we're going to have an open circle. And then this second part, same situation. So that's how we graph it. The other 2 coming up, we're going to identify the same pieces and just go through practice problems. So here's number 2. In this case, we're going to go through the same directions. Our denominator is not factored. So we have to actually factor this first. Our numerator, we can take out a 6. And if we factor out a 6, we're left with 2 minus x. I'm going to take out a -6 because I want to write this in standard form. If I take out a -6, I'm left with -2 plus x. So I can write that as x minus 2. Our denominator is going to be x minus 2 times x minus 6. So our domain, x cannot equal +2 and +6. We have 2 values. Now I have to figure out removable or vertical asymptote. The vertical asymptote is going to be when x is equal to 6. And then our hole, because we can simplify, we're going to divide the x minus 2. So our hole is going to be when x is equal to 2. Again, using these values to identify the holes and the asymptotes. So now we have a simplified rational expression. So now we have to find the intercepts. So to find the y-intercept, we take our simplified equation and we plug in x is 0. So when x is 0, we get negative 6 divided by negative 6, which is positive 1. And to find our x-intercept, we have to figure out what is the x value when y is 0. So we did this before. If y is 0, then technically you have 0 equals negative 6, which does not make sense, which means there is no x-intercept. So this is not going to intercept the x-axis. And now we're going to be able to graph all this and see why this happens. So now we'll be able to graph all this. So we have our y-intercept at 0, 1. We don't have an x-intercept. We have our vertical asymptote, which is x equals 6. To find our horizontal asymptote, you take those leading terms. So x on the numerator and x squared in the denominator. That simplifies to 1 over x. When you're finding horizontal asymptotes, if your denominator has a variable and your numerator does not after you simplify it, it means your horizontal asymptote is where y is 0. So because you have an asymptote when y is 0, it means y cannot be 0. That's why our x-intercept does not exist for this problem. So our simplified equation was y equals negative 6 divided by x minus 6. So our typical rational functions would go in the top right and bottom left. Because this has a negative integer, it means this is going to be reflected. So that's where this red y-intercept kind of comes in handy. So instead of being the bottom left, it's going to be on the top left. And instead of being on the top right, it's going to be on the bottom right. And that's how we would sketch this equation. So we'll do one more, just so you get a better sense of what all these things are. Last one. So, same deal. We have a rational function. This has to be factored because we have a polynomial in the numerator. So x minus 4 times x minus 4 divided by x minus 4. I like using parentheses just to keep it all together. Our domain, x cannot be 4 based on that denominator. So this simplifies, and we can actually cancel an x minus 4 on top and bottom. So we just get y equals x minus 4. So because that x minus 4 cancels, we have a hole. So we have a hole when x is 4. There is no vertical asymptote. Once we simplify this function, there's no denominator. So nothing is non-removable. Everything is removable. Your y-intercept, if you plug in 0 for x, you get negative 4. And then for your x-intercept, you plug in 0 for y, and x is positive 4. So now we're going to graph this. So here's the fun part about this. This equation is just a straight up linear function. So our graph is going to be a linear function. There is no vertical asymptote. There are no vertical asymptotes for linear. Linears have y-intercepts and x-intercepts. The only difference is now we're actually going to have a hole. So no vertical asymptote. The x-intercept, the y-intercept, and the whole. Those are the only things that we need to do. X-intercept is 4, 0. The y-intercept is 0, -4. And the whole was when x was equal to 4. So 0, -4. Y-intercept. 4, 0 is our x-intercept, but it's also where our hole exists. So we still plot that point, but we need to make sure this point is an open circle. So I'll make that a little larger. There we go. And because there's no vertical asymptotes, we're just going to connect these lines. And that's what our graph would look like. So originally it looks like a rational function, but because it simplifies into a linear function, the only thing that changes is that we have this removable point in there. And that's how you would graph all different types of rational functions.